This is a demonstration of the eSync Agent SDK. The Agent SDK has been created as a tool to help you integrate your edge device into the eSync data pipeline. With an SDK, you receive a working client code base, an account on the server, and a template agent. The template agent will be used to develop a custom agent for your edge device. I will describe the platform, and then we'll do an actual OTA update to this platform. On the platform, we have a device labeled as Gateway in the lower right. It's also labeled as RPi1. This is a Raspberry Pi, and the client has been installed in the Raspberry Pi. And it is, we're using the Wi-Fi of this device. It is serving as our gateway. On the lower left, you see another device, which we have labeled as ECU. In this case, it's also a Raspberry Pi, just for convenience sake. But this might be any device, any computing device that you wish to integrate into the eSync pipeline. We have created, using the template agent, we have created an agent for this device, the ECU RPi2. And what we're going to do now is an update campaign to update both of these devices. Currently, the fans are operating in an intermittent mode, and we would like to bring both fans up to full speed, full-time operation. So I will now go through the processes involved in doing OTA to these devices, and we will actually, over the air, install new capabilities to these devices. In eSync, the software is referred to as components. This involves both the software version and the hardware it goes upon. And here you see the component list that is available to me based on my role-based access. I have a variety of software components available, and I can upload new components using the upload component function, which gives me a very simple drag and drop menu for installing new components. Once I have these components in the system, I would then create packages that I will be using in over-the-air updating. Packages are one or more components. And we have this level due to the particular characteristics of the automotive OTA environment, where we have many devices in the vehicle, and we want tools for controlling the installation, not of just software to one device, but to many devices. So packages may be assembled for mere administrative convenience. So for example, we might put all of the software for one domain of one model of vehicle together in one package and label it so that it can move through our organization and everybody knows that all of the components for that domain are traveling together. We may also do it for good technical reasons. So for example, in ADAS applications or active or passive safety applications, we do not want to create an environment in a vehicle where we have untested mixed modes of different versions of software. So let us say in an ADAS environment, we have computing and sensors all tested together on version 1 of software. Now we wish to install new software to all of those devices to bring them all up to version 2. We put all of those software components into one package, and we flag that package as an atomic package. And that means that eSync will treat the entire package as a single transaction, that all devices, all agents will report all devices have succeeded in installing the new version 2, or all will be labeled as failed and mitigation processes will begin, including retries and eventually rollback to the last known good combination. So this is a normal part of eSync, as it must be a normal part of automotive OTA. Now in this case, I'm going to choose a package which we've already created, which is going to bring both fans up to full operation. So we will no longer have at an intermittent operation the description fan 1 full and fan 2 full. So that's the package I'll be using. I'll now move to the campaign menu. And on the campaign menu, again, we have pre-created some material just to save time in the demonstration. I have a campaign that has been created to move the fan 1 and fan 2 full speed into my platform. And I'm going to rerun this campaign. So if I were creating a new campaign, I would go through all of these steps. I'll walk through them very briefly here so that you may see what they involve. The first step would be selection of my package. So in this case, out of the packages that I am authorized to see, there's one package that has been selected, and it will be the subject of this campaign. We could have multiple packages selected for a given campaign. I will then build my vehicle list. In this case, for the sake of the demonstration, we would be choosing make, model, and year. But in commercial deployments, we might have any of the characteristics of the vehicle that would be desired. So it could be make, model, and year. It could be submodels. It can be build pack, and be geographical locations of the vehicles. All of this of the vehicles. From that, I will get my list. So these are the units available that have fit the criteria that I defined in my filters. And in this case, there's only one that I will be updating, which is the one with the VIN number that ends in 868. And so if I go through my list, again, this has been pre-selected. We can see that we have pre-selected 868 as the vehicle I will be doing this campaign to. We would then select the policies for the update. Policy is an important construct within eSync and provides a very significant level of flexibility. In this case, again, for the sake of the demonstration and for the SDKs, we implement a limited set of policy choices just to make things move along reasonably well. In this case, we have network connection, we have installation time, and we have the power mode in the state of the vehicle. But policy could also include a variety of state of vehicles. So for example, we might have not only whether the ignition is on or off, but also if the speedometer reads 0 as a policy requirement, or parking brake is set, or gear shift is in park. We might have, rather than installation time, a user opt-in and user scheduling, which would use the head unit display in the vehicle for the vehicle operator to select the time at which the update will take place. In network connections, we have no restrictions or broadband. We might also have an authorized network of dealer docking bays, as an example, that might be used for particular updates. So all of these are constructs of policy that are available within eSync. In this case, we're going unrestricted, just in the interest of time. And so now we have the summary of our campaign. If we had separated campaign creation from campaign approval, this would be the stage at which my work would end and I would have to seek approval for the deployment of the campaign. My particular role-based access control gives me the opportunity to both create a campaign and deploy it. So I will not be seeking approval. I will be, in fact, deploying the campaign. As this is actually going to be a live demonstration of an actual OTA to this platform, when I hit deploy, things may start happening relatively quickly. So I'll describe what you'll see, and then as it moves through the process, perhaps you'll be able to follow along. When I hit deploy, the campaign goes live on the server. Now in eSync, the server does not contact the vehicle contacts the server. This is a basic construct in eSync. And so each client has a set policy in the client of how frequently it calls in. In this particular platform, it calls in every 30 seconds. So we will have an indeterminate delay, somewhere between 1 and 30 seconds between the time I hit deploy and the time this platform calls into the server. When it does call in, things will happen very rapidly. There'll be a mutual authentication. The server will identify that there is a campaign open to this vehicle. The content will be downloaded to the vehicle. We will see on the display within the platform that the software is being downloaded, but that happens very rapidly as these are relatively small files. Then within the platform, the client agent processes will begin. The client will verify, will mutually authenticate with the agents, will verify that in-vehicle policy is met, and then the agents will begin the process of installing the new updates. And that again will happen relatively quickly. And then when the agents report back successful completion and self-test of the units, then I will receive at the server the indications that there are no longer pending, but successfully completed updates. And all of that will take place again, as we said, very quickly. So we're going to deploy now. So the campaign has deployed and is on the server. And we show that we have 2 pending packages. And we're in that intermittent point where somewhere between 1 and 30 seconds from now, we're going to see this vehicle start its processes. It's downloaded the software already, and now it has begun the installation. It's completed the first installation. I can see on the server that I have one of the two packages installed. Now I can see in the vehicle both have been installed, and within moments it will report back to the server that the process is now complete. I have no more pending packages. I have 2 successful installations in my record. If we look at the platform, we will see that now the fans are spinning at full speed. They are no longer operating in an intermittent mode. So we have successfully updated the operation of these 2 devices. And here at the server, I now have information available to me on this successful campaign. I can look at the security information. These are the security checks that were completed in the client to server interaction, as well as in the client to agent interactions. And if I select the VIN number, I can see the history of the update and even the log of the primary eSync correspondence of the process. So we can see here at 50 minutes, 19 and 50 after the hour, the component, that is the software version, was deployed to the campaign. Version 2.0 was deployed. And about 21 seconds later, the vehicle called in and the client indicated that it has version 1.0. So the download confirmation is requested. The download begins. The download is completed. We're ready to update. The update is processing. The installation record is fulfilled, and the device reports now that it is at version 2.0. And we can export this data, and it is available in eSync in the history of updates to this platform. This completes our demonstration of eSync OTA and the eSync Agent SDK.